Okay. Good evening. Good evening, dear faculties, and welcome to all. Welcome to the AA and ML Faculty Development Program, and welcome to the Pantech e-learning. So, welcome to all. So, sorry for the delay. I hope everything is clear. Right? My voice and the screen. Are any deviations? Yeah. Good evening. Good evening to all. Good evening, faculties. Good evening, Anandavali ma'am. Good evening. Okay, just a minute. Good evening, sir. Sri Krishnan Electronics. Yeah, good evening. I hope the stream is still live. Yes, yeah, okay, sir. Thank you, sir. Thank you. Okay, so I will continue. Everything is clear. Super. So thank you, sir. So now I have to continue. So last session we have discussed about the classification type of two kind of different projects we will see. For our example for classification learning. I mean supervised learning. One of the type as a classification. That perhaps we will see, as well as we will see that two different things, that is music genre prediction as well as the crop prediction using machine learning. So both are different project, but classification using focusing on one particular type, that is classification one. Already we know about that. Today we can discuss about the unsupervised learning, that is the clustering type. Here we can focusing on the one particular concept, that is customer segmentation using machine learning. So that was clustering, that was already in day 3 or day 2 we will discuss about that what is clustering, I mean what is unsupervised learning, that is self-learning one. They have to classify the data in grouping, like grouping format. So they have to grouping the data in a individual clustering type, like one of the association way they have to split the data. That was said like that unsupervised learning, same like as a clustering. Here we can take that customer segmentation based on the one particular supermarket or particular mall customer data we can take, and what is that motto of this particular one means we can classify the group of people based on the spending score wise as well as annual income wise. So how much people give it what is that given high spending score, how much people given very low spending score. So how much people like that particular product or like that way. So review based we can take that particular concept, that is customer segmentation using machine learning. Okay. So what is the introduction of this means? In the field of marketing or clustering can be used to identify the various customer groups within the existing customer data. So based on that, customers can be provided with the discounts, offers, promo codes, etc. So mall data is interesting data that has hypothetical data. On this basis of data, we have divided the customer into various groups. Yeah, sir, just now I says customer segmentation means we can group by the customer into the particular like cluster the customer into the grouping concept. For example, we can take on mall customer data. In that particular customers, so various type of peoples. They are not a same age group people, same gender people is not come on particular mall in public. It's a public place, right? So we can classify it, like we can clustering into the gender wise. So male one of the group and the female is one of the group. Like that way we can classify the customer, or else the age group wise. So adult people and the children's people and the old age people. Like that way we can grouping the customers. That is called as a clustering type as well as customer segmentation. So here our objective is we can grouping the customer based on the spending score wise. Annual income wise, their spending score. So we can't say, right, spending score means the review, like same like as review. For an example, we can take a review. The review means not everyone say give a positive review. Some people will give a average one. Okay, I like just that way they have to say it. Say it is an very poor. Is not I not like the product, like that way. So not everyone to give a good review as well. Not everyone to give a bad review. So that is a mixed one is there in our any kind of products or any things, they have give a mixed reviews only. So that's why the same thing, the same concept also we can follow it here in the customer segmentation as well as clustering. Based on the one uniqueness of focusing on the one particular concept or particular product wise, we can classify the people or classify the data. That is called as a clustering. So our objective, unsupervised machine learning techniques, we are going to make the customer segmentation by using the clustering algorithm. So already we see that is K-means clustering, hierarchical, and what was that? A DB scan. So this is multiple type of clustering is there. So we can see first the most common one, that is K-means clustering. Okay. Okay, just now wait. Yeah. So now the clustering is a type of unsupervised learning, and which the algorithm process our data divided into the clusters. So this okay. So now the scatter plot, you can see the scatter plot. Okay, wait. The name is appear. Yeah, sir, right. So I will take it the yesterday session. So yesterday I plan it for take this particular clustering also in yesterday session, but it's take too much time, so there is no time. I have to take that particular concept. That's why I can take it here. Next we can go with the deep learning also. So no worries. How the deep learning can work? That's kind of way we will see then with the example also. Okay. Yeah. So here you can see there is already we will see the scatter plot. Scatter plot, they mentioning the data in a splitted way, that is across the surrounding they are splitting the data like mixed, or what is that, like crowded way, we can say it like the crowded. In this particular scattered one, we can take that one particular group, that was the clustering. So you can see it is one of the total mall count. So here the people count is that. In that particular overall people count, we can classify the individual group like okay, age group wise. So now the green, blue color, I think blue is that, blue or cyan color is a adult people, green color is an old age people, pink color is a what was that, children's people. Like that way we can classify. So before that, the scatter values are contains the every people's data, so every age group with the combined one. In this particular combined one, we can individually classify that adult people, old age people, as well as what is that, children people. That is called as a clustering. We can make a group that is called as a clustering. So that is called as a K-means clustering. That is one of the algorithm name we can use in this place in a clustering, unsupervised learning concept. So K-means algorithms that can divide the give data into the give number of the clusters. The K number of the clustering that we need to be created. So it is centroid based algorithm in which cluster associated with the centroid. The main idea is reduce the distance between the data points and the respective cluster centroid. So the centroid is to represent the one particular people. So we can say it like the drivers and the police officers, as well as students or teachers. Here the particular name, the name will be representing one particular designation as well as the particular people. So same like here also, the centroids represent the particular group of people's name, like title name, or else the group name, like that way we can say it. The adult people, we can say the adult people, as well as the children's, as old age people. So like that way, the centroid is represented to the one particular label. So now I give an example for it is a workers, group of students, group of business peoples. We have a huge amount of cluster data, scatter data. In that particular data, with the help of the k-means algorithm, we can split it the individual group like based on the shape wise. Like we see the unsupervised learning. We have multiple datas, multiple shape of datas. Based on the shape count, the model can making the group. So here also same like that. Based on the customer detail and the customer appearance wise, they have to split it the customer in grouping the customers. Okay. That is next one is the elbow method. The elbow method means how much clusters we have in that particular data. That was we can make that we can found that. So calculate with the clusters. The WCS, that is called the WCS method, we have to follow. The WCS mentioned like within cluster sum of square error. So how the classification having accuracy score as well as regression having the mean square error like R2 score. Same like us here, the WCS is important for to make it the customer cluster count. Okay. Any number limit to give the number in k. That is based on the data's wise. Data's count wise we can see under the spending score, and also the data's wise we can found the cluster of like k value. So we will see once we are entering the hands-on, I will tell you what are the clusters in our example project. Okay, so now the different values of k and choose for k for which WCSS is first start to the diminish. In the plot WCSS versus the k, this is visible and elbow method. The elbow means one of the graph, the plotting graph. I will show you the plotting in next slide. The steps can be summarized in the below steps. So the below steps of compute the k-means clustering for different values of k by varying the k from 1 to 10 clusters. For each k value is calculated the total within the cluster sum of square, that is WCSS1, and the plot of curve of WCSS, which is the number of clusters k. So the elbow method is represented to the one particular curve. So we have an example. We have taken 5 clusters, means in that 5 clusters, which clusters take the elbow value, the curve value. That is our important thing. That is value of k, the k value. The location of bend, the location of knee and the curve, is the plot of generally considered as an indicator of the appropriate number of clusters. That is elbow method. So now we can see. So now I think we have a 10 clusters maybe. So we can see that. So first starting from the 1 is the first cluster, second is going to the second cluster, and now it's move on to the third cluster and 4. You can see that when the fifth cluster will came, in that particular position the bending is too much take. The knee, the curve is too much take that particular position changing. You can see it here. So comparatively here only the too much bend is there. That's why the 5 here, our k value is 5. 5 is a k value. So now the 6, 7, 8, still it is decreased to the 10th cluster. So for an example, we can set based on the cluster, spending score wise, the annual income will be decreased. Okay. Okay, so next is deep learning. So this is the theoretical thing of clustering one. So first I will explain about the clustering, then we can go with the deep learning concept. Okay, so don't become confused with that. So now we can go with the theoretical of deep learning, means we can make a confusion or else we can forget some kind of things in clustering. That's why first I will show the example of clustering, then we can go with that deep learning. Okay, so as usual, the important libraries of machine learning. So pandas, numpy, matplotlib, seaborn. So everything is there. Once I upload it, then we have to go with that data uploading concept. That was content mall customers. So already said the mall customers is there. I already upload that. So you can see the customer ID and gender wise, age group, annual income and spending score. So in this place we have to take that annual income wise how much spending score in particular people will give them score. Okay. Good evening everyone. Yeah, hi, Muntaz. Yeah, hi. Thank you, Philip Berit, sir. Thank you for your words. Okay. So now, so this is our entire data. So customer ID wise, gender. So in this particular male people, the age is 19. They given their annual income is 15K. So we can approximately fix like that. That is 15K. Their spending score is 39. So they have only less kind of income in per year, but their score has to be a little more. It's an average. We can say it like an average. Comparatively, 100 means it was low, but we can say it like an average. Okay. Why we choose annual income? Annual income, it is not a focused target column. Our target column is spending score. Score wise, the people is which kind of group. There is a high paying customer or low paying customer or mid range customer. Like that way we can select, or we can make that centroid value of particular cluster. Okay. So wait, so we can in upcoming sales we can discuss about that. So in machine learning, okay, major K value calculation for clustering for unsupervised machine learning technique. Philip Bedit, sir, what do you try to say? Major K value calculation for clustering, okay, for unsupervised machine learning technique. Can you repeat? I can understand. So what you try to say, Mr. Philip Bedit, sir? Okay. Okay, so once again entering the cell, we will see. So what that exactly we can take that annual income as well as spending score. So the already said how to installing, upload the data and everything. So next we have already so the df is the data frame. We can execute the head function of first 5 rows of that. Next one is a drop column. So df dot drop the customer ID. So now our customer ID, why I can directly entering to the the column dropping concept means the customer ID is no need to identify the particular customer. So we cannot group the customer based on the ID wise. So that's why the customer ID is no needed. So I will drop that. The axis equal to 1, it helps to accessing the particular column. Entire column we have to remove. So that's why I using axis equal to 1 and in place equal to true to applying the every entire column. That means our original column, like original data, right? That's why. So df dot is it for unsupervised machine learning technique, right? Yeah, exactly, sir. Exactly. So our concept also unsupervised learning. Still the customer segmentation comes under the unsupervised learning, right? But thank you for your elite asking. Yeah, so next we can go with that shape. So already we know the shape is 200 rows and okay, sorry, I'm not run this column, right? Again I can go with that. df dot shape means that 200 rows and 4 columns. Why the variations means because I will drop into one particular column. So only 4 columns is needed to identify the clusters. So df dot info means that the entire information about our data set. So starting from this data frame of our data, the data is having the table format, that was the data frame, and index range, the total entries are 200 and starting to 0 to still 199, and data columns is a total 4 columns, and the column name, null values, there is a no null values because the every count is at 200. In case any null values is there, we can get missing, I mean, some values will be decreased. But that, for an example, 190 means the remaining 10 is a, what was that? Yeah, null values, right? Okay, line 18 mean we removed customer ID, where you can, yeah, of course, sir, yeah. Here the customer ID is there, so the customer ID column is known used to our what was that, grouping the data, so that's why I remove the column. Based on the similarity of data points, we can make the clustering of clustering or grouping with the help of k-value calculation as well. Yeah, right, exactly, Philip did it. Nice. Just a minute, guys. Okay. Okay, where? Yeah. So information already we see it, and institutional functions helps to check the null values. How many count is there in our data set? So there is no null values. Describe function helps to find out the numeric buffering. Still it's buffering. Okay. So just a minute. Still it's buffering or not? Okay, my internet. Okay, internet is okay, fine. Yeah, now it's clear. Okay, thank you, Philip. Thank you, Shalini, ma'am. Thank you. Yeah. Okay, so now I continue. So exactly x is equal to 1 helps to accessing the column, 0 is in row. Yeah, exact answer that Philip did, sir. So thank you for your remaining. Okay, describe function is helps to find out the, yeah, okay, sir, super, sir, Geet Karani, sir, thank you. Describe function is helps to identify the statistical values of our entire data. Here only is showing the numerical columns only. You can see the gender is having the male or female like that, right? So that's why there is not, that particular column is not executed in this describe function. So the age is the minimum age of people is 18, maximum age of people is 70, and in our data set, as annual income is minimum level is a 15k, maximum income is an 137k. That means around 1 lakh, right? Spending score is a minimum 1 and the maximum is a 99. So already I said this, right? Not every people is equally give that score or review. So each people is given different reviews based on their thinking like that. So now the group by functions helps to, okay, overall mean value of male and female, like gender wise they have to split at the mean value of every column. So df dot group by function helps to that based on the gender column wise each repeated value, that is male and female only is there. So female is mean value is 32 is an average mean value, and annual income is 59th what was that mean salary of annual income, and spending score is 51. Same like that, male is comparatively is deferred. 39 is a mean value of age group, annual income is 62, and spending score is 48. It's a mean value of both gender wise. Okay, next we can go with that, see the correlations of the both three different things: spending score, age, and annual income. It helps to give the distribution plot. The distribution plot is equally assigning the value in stage minimum to maximum level of the values. That's why the distribution plot helps to assigning the equal distribution of entire values. So first the PLT dot figure is helps to 16, 12. We can calculate the mean value for categorical columns. we can calculate the mean value for categorical columns. Oh, okay, fine. You can talk about the particular individual thing, like label wise. We can find out the each category. So male and female. Categorical columns mean. Yeah, female's mean value and male female value. Mean value. So almost the figure value is helps to make that plotting size. So how length and width. That's the figure size will help to assigning. We can change it, like modify the figure size based on our requirement. Then again, now I give to the 16 length and the 12 width, like that way I mentioned. So the subplot is helps to, in single frame we can create the multiple pictures. Okay, so plt.subplot, the 3,1,1 means that is the count of the rows and columns and of the position of the picture. 3 means there is a 3 columns. So 1, 2, 3, 3 columns and a single row. The 3 pictures mentioning in a single row. That is, we can mentioning like a 3,1. The last one value is a position of this particular picture. Okay. So the plt.title, we can assigning the title for that each plot. I mean each picture, and cbound is dot distribution plot. So SN is a cbound. Already I said this. The distribution plot is an one unique plot. So how the line plot is there and the count plot. What was that? Scatter plot. Same like that. Here the distribution plot also there. So the DF of our data, we will find out the distribution plot in column. I mean spending score column in the first plot. Second one is having the age plot. Third one is the annual income plot. Okay, that's where we can assign it here. So we can individually show and each picture. So first is spending score, second is the age, third one is the annual income. So now I run this, you can see it properly. Okay, the first is having this spending score. So starting from the minimum value to still maximum value wise, they have to distribute it equally based on the density wise. The values are equally distributed. Yeah, right. So most of the people is given to the mid range of spending scores. So medium level of spending scores they have to provide. So most of the people. Here the most of the customer range is 20 to still below 70. So now our you can see our age people said starting 18 to 70 and spending score. Yeah, that was starting 1 to still 90, 100 near. So you can see that shade, the particular shade starting from the 1 to still 99. The line plot is the what was that? The range of that particular values. The line will assigning the range of the particular value. The blue color boxes will be represented the how the values are equally splitted, like distributed. So age also same like that. Starting from the 18, so near 20, 18 to still 70, right? 70 or 77. Maximum age 70, yeah, right. So maximum is 70. So nearest to 70. And annual income also same like that. So minimum is 15 to still 1,37,000 like that. 137K we can say it. So the values are equally split like distributed into based on the shade, the blue color shade wise. The line, how the range of the value is there. So next one, the gender. So gender is the how many count. So how many males and how many females, like that way. The value counts already said. Value counts just helps to. The value counts just helps to most of the. How much values is in each category. So female category have a 112. Male category is an 88 count. Next one, label encoder. So here is executed because why we can using the label encoder in this place, we can pre-processing the data, like transform the data into object to still numbers. So here we can gender column as an object like male or female way. So label encoder we can assigning to transform the data in an automatic way. So you can see the encoder will, that's object name, and the label encoder is a model name. Here here the encoder.fit transform is the each gender column we have to transform into the object to or like text to number. So we can assign the same value in a same column, like gender column. That's why I can mentioning the df gender. So once I run this, again we have check it. So before that I have to check df dot head. So you can see the 1 or 0 like that. So 1 is a female, I think, right? Yeah, 1 is a female, 0 is a male. Like that way they have to initialize. Next we have to check the correlation of this particular data. So df dot correlation is helps to find out the every columns is equally predicted or not, like equally what was that relationship between the each same column as well as another column. Here you can see the spending score is and spending score, the both are equally split into the one. The yellow color is represent to the positive one. I mean what's that, positive, true positive, true negative, sorry, true positive, false positive, true negative, false negative. Like that way we can represent the correlation. Here the same column, the true positive means the same column. The true positive is equally predicted, that was one value, that is highest value. When the value will be decreased, it means that is true negative, because the spending score we comparing with the annual income, that was nearly 199, like nearly 1, the mentioning like a 0.99. And the spending score to age is a very negative, true negative, that means it's a very less value, comparatively it's above 0, above or below 0, right? And gender also same like that, because the customer spending score is equally predicted and the annual income also equally predicted. It's nearest one as well as our target column also. And here the annual income to annual income also same like that. So you can notice that age and gender only is taken too much variations comparatively annual income and the spending score. Okay, so this is there we can see that correlation between the same column as well as different column. Yeah, so next we can go with that value counts of gender. Now we can confirming the transformation, that is 0 is a female, 1 is a male, right? And again we have to check that for confirmation. So our entire column has to be changed and properly converted. Yeah, right. So male is a 1, female is a 0. Here we can find out the overall spending score of every male people as well as every female people. Spending score of every males and spending score of every female. So with the help of the what is that? Yeah, with the help of the for loop we can easily find out the overall score of male and female. For I in range of len and the length of df, that is our data frame. The data frames helps to the gender I is helps to execute the value one by one. When the gender column will be there in equal to 1 means that is male one. When the value is equal to 0 means that is female value. So the values are combined with that spending score, like add it, every value one by one they have to add it. First male spending score, second male spending score, third male spending score, like that way. One by one is executed. Totally we can find out the every male spending score. Here you can see the data. So there is a first male, so 1 is a male, right? So this male's spending score is 39. So again the second male spending score is 81. Now the both values are added. The every value adding, the final sum of value is like here. So male spending score is 4,000, female spending score is 5,000. Because most of the places the female only is going to the shopping in malls. So that's why the female count is too much there. Okay, once I run this, so you can see there is 4,200 as males, 5,700 as female. Okay, so next we can go with that graph. Age wise spending score, annual income wise spending score. Then first the plotting are represent to the age and annual income wise spending score. How the spending score is there, age range and annual income. So you can see that some figure already we know the size of the particular picture, and scatter plot already I can set this. The values are scattered based on the values data values wise. SNS.scatter plot, the x is a age column, x axis having age and y axis having the spending score. The title is an age to spending score. The text size is 23 and color is in red. So here is a customized one. We can change the color also. If I give that black means we can check. that was black. That is a customized one. We can easily modify that. And size is our font size, so we can change the font size also. So 15. Oh, sorry. Okay, now. So here, what was we can see in this picture? We can. Oh, sorry. So you can see. So starting 18th age to still 17 age wise, each age people age wise, how much spending score is there? So almost the 18 age people is giving to the nearest 10 or 10, not like the 10. It is 5, maybe 5 because 20 now. So 5 or 8 or 10. So most of the 18 people is give the score like a small to still highest one. And range of 30 age people and 40 age people, most of the peoples are giving smallest to highest spending score wise above 40, right? So yeah, above 40 age people, they are not more than 60 score. They are above 40 people, like adult people, most of us, they giving a below 60 only, below 60 spending score, still a 70 wise. Here we can easily find out the two kind of group, 2 or 3 kind of group. Here the less age people, I mean minimum age people is giving this less spending score as well as highest spending score, as well as average or adult people, they are giving to the most of us, they are giving less spending score as well as medium spending score. Oh, okay, just a minute guys. So behind me some races. Okay, just a minute. Now the shade is not the right. Yeah, fine. Okay, now I have to continue. So just a minute. Yeah, okay. So now I have to continue. So here the age group wise the customer clustering. So that was, we can say like a K-means clustering. So next we can go with that. Yeah. Relationship between the annual income and spending score. Before plot we can see that age group wise annual income. So next we can go with that income wise spending score. How would make a cluster from scattered data? So now I can just approximately we can given one kind of clustering. So you can see that the most of the 30 plus age, so below 40 age people, they give it the highest spending score. You can see that there is almost above 30, right? Most of the people. That's why approximately we can give a prediction. So we cannot set exact one. So just an oral thinking like that way, right? So now we can see the annual income. Income wise the spending score is how much is that. Here also same like that, we can easily predict that value of 20 to 40 age people is given to the income, 20 to 40k income earning people give a minimum level of like not more than 40 spending score, like 40 spending score. Same people let's give like a highest spending score. You can make like a lowest and highest we can take. Now here the less earning income people give a less score value as well as highest score value. So average income people earning income earning people, you can see there is an average score value. So near 40 to 60k people or near 40 to 70k people, most of us they give a same range of 40 to 60 spending score. Same highest income earning people give it low spending score as well as highest spending score. Okay, now. So that way now the clusters wise we can see like we can take one kind of prediction in our own way. In my prediction way I can say it like this. Okay, so next we can choosing the number of clusters. So df dot head function is helps to same thing as executes in the data, and we can see individually age wise only the continuous values of age peoples. So people age iloc of 2, 3. Okay, just a minute. Index out of bound. Okay, now I think it is represent to the age and the income, right? So you get some confusions. Just a minute. Yeah, almost. iLog is an index locator. They have to find out the particular index number wise. They have to give a data. So now I show. Okay. So df dot iLog of of 2. So you can see now I give the 2 means the second index row will be executed. Based on the index number wise, they can locating the particular data point or data value. Here 2 means that is second index. Second index is the female is there, and the age is 20. The annual income is 16. The spending score is only 6. So you have to confirm this one. You can check it over our data set. So df dot what was that? Head. Yeah, right. Head. So now you can see the second index having female, same 20 age female as well as 16 index, and spending score is a 6. If I give it to, oh sorry, where is that? Yeah. If I give a 4 means that is fourth index. You can see that the 0 same female, 31 age. So what was this represent to me? This starting to ending rows, but the columns are second column and third column. Second index column and third index column. So why the 2 means everyone can think the 2 means age and income only we need. So but we can get annual income and spending score, because the index range of gender is a 0th index, age is a first index, annual income is a second index, spending score is a third index. So that's why the 2, 3 means second index column and a third index column, that both values will be executed here. So I have to execute the values of starting to ending point of entire rows. Here the bracket is represent to the columns of particular data. Here I can mentioning to 1, 2. You can see that 1, 2 means that is age and gender. Sorry, age and the annual income. Now I again executed the x. You can see that the highest value, the age is not more than 70. You can see same 0, 1 means that is the gender and the age. Now we can understand so how the iLoc will be help to execute at the values. So but we need a annual income and spending score entire values. So again I have to give the x, so annual income and spending score. So now we can check the cluster value of first 10 ranges. From sklearn.cluster and import the k-means. Here we can create the model. Same like that we can create the model and we can find out the cluster values for each each range. So WCS is a within cluster and sum of square. That is already we see this. That helps to create the number of clusters. How much number of clusters is there? So for I in a range of 1 to still 11th ranges. So starting 1 to 11th row, and k means equal to n number of clusters is equal to I, and the init function is helps to k means cluster, and the random state is a 42. So already said random state helps to stabling the score value. K means dot fit means we can initializing the x value, because this is our input to train our model. Already we can see in the machine learning the x is an input one, y is an output, actual output. So here also we can follow the same step. So k means our model. We can dot fit means that is a training process. We can fit it our value into our model. So WCS dot append of k means dot inertia. So we can initializing the values, I mean the WCS value in a k means model. Finally we can execute like print the WCS. They have to show the cluster value of a top 10. Yeah. So once again I run this. So it's the first cluster, second cluster, third, fourth, fifth, 6, 7, 8, and then 9, and then 10. So highest cluster values only is executed here one by one, like steps. What was that? The terrace steps, you know. So like the steps wise they have to initialize here. And next one's the elbow graph. So here how the clusters will be create in the number of clusters starting 1 to still 10. So already we can find out the cluster 10 clusters. So the values are executed how they the elbow method will be applied in the which kind of cluster. So I will show the graph, one graph, right? The graph, that particular graph we can see it in this particular place. So in our data there is 10 number of clusters, and here create the plot of the range 1 to 11, the WCS value applied to the 10 number of clusters. The title is the elbow point graph. X label is the number of clusters, Y label is the WCS, already we know. The name of the axis, X axis and Y axis, the show value. You can see there is the highest range, the 28 to still 2000. So sorry, 26 to still 2000 will be that is a less value of this. So you can see the starting from the 26, the range first cluster is having the 26, second cluster is going to the how much? So 18. So nearest 18. You can see the below 20, and third cluster is a 10,000. So now again it's near to the third cluster, it comes to 10,000, and fourth cluster is 7,000. So yeah, so here the fifth cluster only is take a too much bend, like too much knee bend. The curve, the too much curve is the fifth cluster only having too much curve is there. So that's why our k value is in 5. So next you can see the very minimum range, minimum decreased value only is there. So again the 4,440, so the 444 is there. Again is going to the 4,000 and the 3,300 and the 2,600. The ending value is in 2,300 only. So like that cluster values are like decreasing the like this very minimum steps. After the fifth cluster, the very minimum steps to take the remaining clusters. Okay, so now we can see the clusters count. So which one is the which kind of cluster, like that. So first value is in third cluster, second is a fourth cluster, again third is a third cluster, right? Fourth is a fourth cluster, fifth is a third cluster. Like individual people, totally 200 entries only have in our data. So the entire 200, which people comes under the which kind of cluster type. So starting with 0 means 0, 1, 2, 3, 4, 5 clusters, right? Our number cluster count is a 5. So that's why. Finally, we can find out the cluster. We can assigning as a y. Then df.head. So we can creating the third cluster. So another column that was cluster count. So first people comes to the third cluster. They like a third group. Second people comes to the fourth group, and the third people comes to the third group. So like that way. So which people, which kind of group they have to comes. That's why we can see. And cluster values of total value counts. So 0th cluster there is 81 people. First cluster is first group they have 39 people. Second group is 35 people. Third group is 23 people. Fourth group is 22 people. So it is a value counts text wise. Same thing we can see it in a count plot wise. So we have initially we need a different thing, means we can using the hue. Hue is helps to assigning the different color for each values. Now we can see highest to lowest. So next one we can create the dummy for our data frame. So dummy variable we have to create, like assigning the y, that means our clusters into the dummy one, dummy data. And here that is first 5 rows. Head is represented to the first 5 rows. Okay, already you know. So dummy 0 dot value counts means the first index. Yeah, 0th group, how much people is there, that's where the values are executed. So 81, 39 and every values is there. And again we can check the y columns having the number of group, so third group or fourth group, like that way. So x means the annual and spending score wise. So already we see that x. Here we can give a comparison of this. X input is equal to y is equal to 0. When the y variable, the clusters will come meet into the 0, the values are executed like 39 to still 76, like annual income wise. And k means dot cluster centers. Centroids, already said the centroids. So k means of cluster centroids. So we can find out the values of every cluster. So now we can see that the array value. So you can see the 39, 40, the every values will be stored into the array format. Sir, if data set size is 800 cross 300, then to use a deep learning is valid or not? So you can talking about text data or image data. So whatever it is, the deep learning is most helps to identify the data count and everything. Okay, it's very complicated, right, sir? I accept this, but once you can try with yourself, you can get an idea, some idea for, and the concept of this particular clustering you can easily understand. So now you can listen only, so that's why you can getting some confusions. So once you can, I will share this code into yourself, I mean your WhatsApp group. Once you can take it yourself, and after the seeing the video, you can easily understand your understand this concept. So PLT.figure already we know. Oh, voice data. Right, just definitely deep learning is needed for that. That was not, deep learning is not only a text, so it is acceptable for every data, voice, video and image, everything is that we need a deep learning. And yeah, so now we can showing the picturized format. I will assigning the centroids color is a green, red, and individual color for individual clusters. So cluster 1 is a green, cluster 2 is a red, and cluster 3 is a yellow, cluster 4 is in violet, and cluster 5 is in blue. And the k-means cluster centroids will be executed one by one, and the color centroid color is in brown. So we can give it a different one. We can try with the black. That was showing good. Comparatively, they has to be show good. Okay, now. So now we can see the green is in first cluster. So now it's a first cluster. Red is a second cluster, and yellow is in third cluster. Next, violet is in fourth cluster. Blue is in is a violet. Right? 1, 2, 3, 4, 5. So like that way they have to create. First, the average people, most of the people spending to the average score values. That's why it's a first cluster. Next, comparatively, the highest score in the highest spending, I mean, annually, earning people, that is the second cluster. Highest earning people, we give a low spending score, that is a third group. So based on the count wise, they have to assigning the order. Is the highest one, comparatively it is less than. Comparatively both, this is very less. So like that way, they have to assign. Okay. Next, okay, yeah. So now we can understand. Next is a PCA value. PCA helps to transform the each value into the decomposed. PCA already I said the PCA is an helps to reducing the dimensionality of the value. Like we have one particular customer like scatter data we have. In that particular scatter data we have to specify the each group, like each clusters. So that's why the PCA helps to reduce the dimensionality of the data. So this process will be happening like this. Okay, what? Buffering. Okay, how much time it's still buffering? How many times? Just now I noticed your command. Oh, now it's fine. Okay, fine. So, thank you. So I don't know why it's still again it's come suddenly. Okay. So the PCS helps to principal component analysis. So that was, it's around 1 minute. Oh, okay, sorry for that. I don't know why it has happened. Okay, fine. Yeah, so the PCSM principal component analysis already said it helps to reducing the dimensionality of that particular values, our data point values. That's where we have do in this place. So to reducing some kind of values in a minus, so minus values are there or plus values. So unwanted data or any unwanted dimension array values is that was everything will be reduced for our cluster making. So after that we can check, where here. So again we can check. Okay, again we can check means in this time we can get it to the two kind of clusters, because we have reduced some dimensionality. So that's why the elbow method will be there in a second cluster. You can see the second cluster is taking too much bending, like too much curve in our clusters. Okay, same count, same 1 to first 10 ranges we can take. Here we can take the two kind of clusters for our curve, like our number of clusters. So again we can initiate. You can see this time the entire shape will be changed here. The first cluster is here. So in this place the PCA analysis the variable 1 and variable 2 wise we can analyze that. So here okay, the PCA and the PCA 1, 2, the both are equally splitted to for not about 2, so equal to the second centroids. So second dimensionality, we can see that first customer cluster and the PCA variable 1, PCA variable 2, we can assign to the red color. Almost the cluster will take it from our first clustering, group. Here already we see that cluster grouping, the customers group. Same thing we can do it in a PCA process. A PCA is an additional method. How the models car price prediction, we can car price or crop price, I think anything, any one kind of project I will said we need another model for our cross checking. So in case first model is having less value means we can take that another model. So like that way here the PCA also same, like to check it our clustering group. Okay, so this is the way we can find out the clusterings, like group of customers. So customer segmentation concept. I hope You have 50%, most of the people you understand this, right? So once you try with yourself, you can definitely understand this concept. It's little more difficult to understand, so please try how it has happened exactly. So now we don't have a time, so we can entering into the next one, that was deep learning concept. So deep learning is already, we know it is a subset of machine learning. Without deep learning and machine learning, we cannot create the artificial intelligence concept, like the final product of artificial intelligence. So what is that exactly the deep learning means? The subset of machine learning. It involves to use artificial neural network to model and solve the complex problems. So like structured data to unstructured data, like that. Structured data means our data set. So text is here, like text data. Almost text data or number data only is the structured one. Otherwise the voice and the video, this kind of things is the unstructured data, right? So the deep learning only have a what was that? The ability to handling the particular every data. So these neural networks are composed of many layers of interconnected nodes, which allow them to learn increasingly sophisticated representation of data in over time. Over time means every time. So deep learning has been used to achieve the state of the art, so result in a wide range of field, including the computer vision, NLP, as well as speech recognition and robotics. So everywhere the deep learning has to be initialized. Most important thing, the image concept. You can take it. Yeah, structured data is a machine learning. Yeah, almost. Because that data set is a order format. Like they have a initialize. So they have a what was that? Individual labels and format is that. But unstructured data is not like that. So we have to make it properly. After that, we have to do that prediction for machine, like train for machine learning, and we can do that prediction. So here is the process. So input, this is the way the values are splitting. In deep learning, the neural network, we have to create the process of deep learning neural network means it is input. The input has to be goes into the individual neurons. Neurons where they have to go. Already we know. So the deep learning will be working like a human's brain. The brain will pass it the information with the help of the neural network. That means the neurons in our body. So same like that here also. Our data pass it like the information will pass it like a neurons count. That is x1 is one of the neuron, x2 is an second neuron, and x3 is a third neuron. Neuron wise they have data has splitted and pass it to the layer by layer. So the neurons that contains the data is move on to the one layer to another layer. Definitely we can get the Bayes value and the weight value. How much minimum rows required to use deep learning for 300 features? Yeah, Pawan Kumar sir, first I have to see your what was that, your project. After that I have to give a suggestion. So yeah, orally you can ask me. I don't know exact answer for you. Okay, if you know means I can say it. So I have to refer something. So kindly you can share your details of what kind of question you have. You can individually give a message in the WhatsApp number. I will share in the end of the session. I will share your WhatsApp number. You can give a message in the WhatsApp number. We will discuss about in that group or WhatsApp. Okay, now we don't have a time also. First I have to understand your question and your doubts. That's why I can reply to you. Okay, so kindly you can contact the number. Yeah, thank you sir, thank you for your accepting. Yeah, so same like that, the input will be passing into the one by one neurons. The neurons having individual weight value. The weight value applied by this formula in every layers. Okay, and okay, the image will be little more discussed. Yeah, right. First, the input layer means that is that in that first layer only the data has to be splitted into neurons. After that, every neurons is passed into the every cells and every networks. So in cross values also that the first is neuron going to this here and everywhere. So in this process based, the every image has to be, the image pixel values has to be converting into the neurons. Finally we can got one particular output. So here the first neuron is contain the one by one. yeah, x1 and x2. So point 1 means it's going to the h1 and h2. That is a hidden layer. h1 is represented the hidden layer. The o1 is the output layer. So the first neuron contains the weight value also is passing to the first layer, hidden layer. It's going to the weight 1 and weight 2. Again, it's a weight 3 and weight 4. Oh, sorry, weight 1, weight 2, weight 3 and weight 4. Same like the hidden layer to output layer. Again, the another weight value is the weight value helps to decide what kind of object present in that particular data, like image data or structure data, whatever. Neuron means a deep learning. Yeah, of course, yeah. Neural network and neurons, everything is there. That is comes under the deep learning concepts. So now we can see we need output like a elephant image, but our input just then we can give the image that just we can give the image only. In that particular elephant image is the individual data split. Now I said the image, sorry, we can using the image data, we have multiple layers. So one layer is not enough to identify the particular object. So we need a multiple layers to identify the one particular picture, input picture. So here the elephant picture is there. So in the on the particular picture pixel values is converting into individual layers, I mean individual features. So like this, the single lines finally is combined with that one particular object. The model has to find out the image is the elephant image. Okay, so as a user we know about this. It's an elephant, the picture is an elephant picture. Same thing, the computer has been recognizing the picture, right? That's why the first layer is splitting the pixel value based on the values wise. They have to draw the one particular edge deduction, like edge line. Finally, every line will be assembling in a one thing, that is a flattened layer. The output layer will decide the object is an elephant one. So like that way the processing will be there in a deep learning. Okay, so this is the way the deep learning has to be in work. So it have a too much thing. We have see the example also we want to see. Okay, so just basic understanding you get, right? You got, I think, how it is working. The deep learning helps to weight value. The weight value is okay. What was this? Geet Kanani sir said about. Just a minute. I have to change. Okay, what is weight value? Yeah, the weight values is first they randomly initializing the data, then they update the data to final output. For an example, we can make on product, sir. Okay, any kind of the cooking or any kind of things we can make, any dishes or any product. Definitely we can get a loss values. So in that particular losses, some people they have to using the recycled one, so they have to using reuse also. Same like that here, we can pass it our data. One network to another network, the data has to be processed. I mean, it is send it to that. We can getting some kind of loss values. The loss values will be calculated by that particular data's weight. Finally, we can try to initializing the particular weight value into our exact data. That helps to enhancing the object to found for our model. That's why the weight value will used in this place. Exact meaning of the weight values are first the randomly initialized and then learned the updated and optimize the network during the training process. Just now I orally said it helps to found the object for our final layer. Okay, so these are all the deep learning things. So already I in reminding this one, so already remind that again I have to give a reminder to you. So we are conducting the 3 upcoming masterclass series, that was next generation AI agents and the DevOps. Oh sorry, just a minute. Yeah, sorry. So now next generation AI agent, that is starting from the October 3rd, and DevOps is starting at the 24th October, and AI vision engineer with Hugging Face and YOLO models in 14th November. So these are all our upcoming masterclass series. So anyone can interested, so kindly join with our masterclass, upcoming masterclass using this QR, or else we can share it the link in chat box as well as our WhatsApp group, and everywhere we can share it link. So anyone interested, you can join our masterclass, or else you can share it with your friends or your students. It's most helpful to them. Okay, so now wait, the session was not completed. Again, our process is there. It's now your time is there, right? So find out the logos name. So previous session we will see that first thing we have see the programming languages. In second or third day we will see the you will see the particular what was that AI tools part 1. Last session we will see the part 2 of AI tools. Now we can go with the general logos. Okay, faculties kindly give an answer for this logos name. So before the session, everywhere most of the people give an answer, and I'm really happy to that. So it is the last day, so we can end with this FDP in this particular logos. Is in our daily life we can use this. So try to find out that which logo is which kind of type, like which kind of application. Second one is a messenger. Okay. Third one is a WhatsApp. Super sir. Fourth one is a Twitter. Okay. Narayana Modi sir already gave 3 answers. Second one is a messenger. Third one is a WhatsApp. Fourth one is a Twitter. Sixth one is a Snapchat. Super sir. So what about first and fifth? Second is a Telegram. Oh no, ma'am, that was not a Telegram. Already sir will give a message. I mean, answer that is a messenger. Yeah, exactly. Which one, sir? Nelson Varthe, sir. Which one is the old logo Instagram? First one is a camera. Oh no, sir. No, that's not a camera. Okay, first one is Instagram, Facebook, Messenger, WhatsApp, Twitter, YouTube, Snapchat. Super, sir. Git Kalani, you can give an entire logos answer. Okay, maybe it's easy one, so most of the people you can find out. I take an old logo, old social media logos. This everything is an old model of our social medias, trending social medias. Yes sir, exactly sir, Nelson sir. Yeah, thank you. First one is a Instagram, second one is a Messenger, third one is a WhatsApp, fourth one is a Twitter, and fifth one is a YouTube. It is a old, it is a nearest 2005. In 2005, the YouTube logo like this, like this. Snapchat, it is a 2010, 10 I think 10, 12, nearest to 12. That range, the Snapchat logo is there. Yeah, first one is Instagram, exactly, right. Okay, thank you faculties. In this 5 days FDP program, I'm really glad to share my knowledge to you. I hope most of the topics I try to understand to you. I mean, give an explanation. Whatever I know, I will share my knowledge to you. So you have any doubt, you can ask anytime to a WhatsApp group, and the mobile number also I will share. WhatsApp number and my email ID, everything will be there. So you can contact anywhere or like any time to us. So now you have any doubt, you can ask. So you have any doubts related to your what was that? Your thesis related or any project related. So you can contact with this number. We will discuss about that. So Viru. So no issue, sir. That was not a camera. That's an Instagram logo. That is not thing. It's an old logo. Sometimes we can give a mistake, right? Okay, thank you all. Thank you so much. Thank you for your responses. In these 5 days, most of the people interacting with me. So that was really good, and thank you for that. Which registration link, ma'am? Oh, thank you, sir. Thank you, sir. Narayana Murthy, sir. Thank you. And special thanks to 1 or 2 people. So they are so much interacting and asking lots of doubts also. like Ashok Yadav sir and Geet Kalani sir and Veeru sir. They are also Manavalan sir. He is repeatedly. They give us some appreciations as well as questions and responses, everything. So thank you for that. So Tenmali ma'am and Ashok Karo sir. So everywhere. So most of the people you give an answer. Thank you for that. Thank you. And Pawan Kumar sir, definitely you can give a message. We will discuss about your speech. I mean audio related deep learning doubts. We will discuss about that. Today or tomorrow we can try to make a conversation about that. Yeah, Bonali ma'am. Yeah, you ma'am to find out the every logo's answer. So super ma'am, and thank you for your responses. Yeah, Ananda Valley ma'am. Oh, yeah, Snapchat. Yeah, exactly ma'am. Nice Snapchat. So if you have shared anything so about my communication or else my teaching and anything, you can say any suggestions. You can share it your reviews in the particular feedback link. Already I said in start of the before the FDP start, I said so. I don't know how many people give a review. So kindly give that. That is most helpful to me and us. Yeah, already we will share it in a 3 days thing. So in upcoming 4th and 5th day only we have to share. So today or tomorrow morning we will try to share that resources also. So thank you all. Thank you so much. Don't forget to give our day 5 attendance. And your feedback, that only motivated to us for improve ourselves and given more tech updates and tech related contents we have to make for our motivating. Okay, so I hope everyone can understand. So if it is possible, we will meet in another FDP also. So stay tuned with us. Kindly to follow our channel. For more tech related this kind of upcoming workshops and FDP programs and masterclass, everything you can get immediate update. Kindly subscribe to our channel and follow to our channel. So whatever we need, whatever we know, we can try it and share it to yourself. Okay, you missed the yesterday attendance due to network issue. Okay ma'am, that is not a big issue. We will try to share it in a WhatsApp group. Okay, thank you all. Thank you so much. Shivashankar Reddy sir. Sorry sir, we can't share it available. It is possible to share today's link or we can try to the yesterday link, but we cannot share that day 3 link sir. That was already closed. That was not an issue, so we can manage. Yeah, thank you sir, Bharatraj sir and Sujana ma'am, thank you. Okay, thank you all. Thank you for your support and your responses and everything. And you will share it your answers like last every session I will said. So you will give an answer here, but you can try your answer in a review page or our LinkedIn page. Once I share it over our LinkedIn page also, so you can try to share your answer in that particular LinkedIn page. Okay, just a minute. Yeah, this is our LinkedIn page. So you can share it your so you can search with the Pantech e-learning. You can get it our LinkedIn page. So you can share it your answers and your reviews, everything, and mention our program name or anything you can share or suggestions or your reviews. That was most helpful to us. Okay, so this is our LinkedIn page. So don't forget to share it your things. And thank you all. Thank you so much. Thank you for your attention. We will meet in the next FDP and see you.